Okay, balancing equations race. I'm going to show my strategy that I used last year, I think. So, firstly, we have C3H8 plus O2 yields CO2 plus H2O. Over here, we have three carbons and only one carbon over here. We're going to put a 3 there to match, to like balance the carbons out. Over here, we have 8 hydrogens. Only here, we only have 2 hydrogens. So we're going to put a 4 here to balance the hydrogens out. Over here, we have 3 times 2 is 6, plus 4 oxygens is 10 oxygens. So to balance it out over on this side, we're going to do 5 times 2 is 10 oxygens. Let's put a 1 over here. Let's double check. We have 3 carbons over here, 3 carbons over here, 8 hydrogens over here, 8 hydrogens over here, 10 oxygens over here, and of course 10 oxygens over here. So this equation should be balanced. Nextly, Al plus Fe3N2 yields Aln plus Fe. Over here we have 3 irons, so let's match it over here by writing a 3. We have 2 nitrogens over here, so let's match it over here by writing a 2. And now we have 2 aluminums now over on this side, so let's match it over here by writing a 2. And this should be a 1. So let's double check. 2 aluminums, 3 irons, 2 nitrogens, and of course 2 nitrogens. And this equation should be balanced. Nextly, we have NaCl, Na plus Cl2 yields NaCl. This is a synthesis reaction. So firstly, let's match the chlorines. Over here we have 2, over here we only have 1, so let's put a 2 here. But now we have two sodiums over here now. So let's match it over on this side by writing a 2. So and this should be 1. Let's double check. 2 sodiums, 2 chlorines, and of course 2 chlorines. And this equation should be balanced. For question 4, we have H2O2 yields H2O and O2. This seems to be a decomposition reaction. So we're going to break this down into H2O and O. So how many O's here? We have 2 O's here. Over here we have only 1 O. So we're going to do 2 of these oxygens. But now we have 2 of these H2Os now. So let's match this by putting a 2 over here. And this should be a 1. So let's double check. 4 hydrogens. We have 4 oxygens. We have 2 oxygens here and 2 oxygens here. 2 plus 2 is 4. So this equation should be balanced. Nextly, we have C6H12O6 plus O2 yields H2O plus CO2. So firstly, let's examine what kind of reaction this is. This seems to be a single displacement reaction. We can see the hydrogen moving to this oxygen to create water, and the carbon and oxygens just become carbon dioxide. So we have 6 carbons over here, but only 1 carbon over here. So let's make this a 6. We have 12 hydrogens over here, so let's make this a 6 because 6 times 2 is 12. Let's examine the amount of oxygens we have. We have 6 oxygens over here and 12 oxygens over here, which makes 18 oxygens so far. So we have 6 oxygens over here already, but so we need to make 18. So we need 12 more. So let's put a 6 over here, and this should be a 1. So let's double check. 1. So we have 6 carbon over here. We have 6 carbon over here. 12 hydrogens. We have over here we have 6 plus 12 oxygens is 18 oxygens, and over here we have 6 plus 12 oxygens is 18 oxygens. And this equation should be balanced. Nextly, H2O plus CO2 yields C7H8 plus O2. This equation, it seems to be the Okay, the seems to be a double displacement reaction for some reason. So the carbon here switches place with this oxygen, and you know they yeah I can't. It's kind of difficult for me to explain. So let's just do it. We have one carbon here. We have 7 carbon over here. So let's put a 7 to match the carbons on both sides. 2 hydrogens over here. We have 8 hydrogens over here. Let's make a 4 to match the hydrogens on both sides. Let's examine the amount of oxygens we have. 4 plus 14 is 18 oxygens. Sorry, that looks like 180 oxygens. So we need 18 oxygens over here. So let's make 9 times 2 is 18 oxygens. This should be a 1. Let's double check. So 4 times 2 is 8 hydrogens. We have 8 hydrogens over here, 7 carbon over here, 7 carbon over here, 18 oxygens. We know that. And over here we have 18 oxygens. And this equation should be balanced. Nextly, we have NaClO3 yields NaCl plus O2. This seems to be a decomposition reaction because we can see the oxygen here disconnecting it from this compound. Yeah. So we're going to treat this as like as one thing because it doesn't separate. Okay. So let's match the oxygens first. Over here we have 3 oxygens, and over here we have 2 oxygens. So in this case, we need to find the lowest common multiple, which is 6. So over here I'm gonna put a 2. Over here I'm gonna put a 3. So on both sides we're gonna have 6 oxygens. But now there's 2 of this NaCl now. So I'm just gonna put a 2 here, and let's double check. 2 sodiums, 2 chlorides, 2 chlorides, 6 oxygens, and 6 oxygens over here, and this equation should be balanced. Okay, question 8. NH4 3 PO4 plus PP NO3 4 yields PP3 PO4 4 plus NH4 NO3. Okay, keep in mind I don't know how to say these brackets. Okay, it's been quite a while, but we notice that these are not separated. They've kind of just displaced themselves, right? Yeah. So this reaction is a double displacement reaction because this and this apparently switches places. So the lead goes with the PO4 now, and the NH4 will go with the NO3. So I'll just make this easier to read for you. Okay. So over here we have 3 of these NH4s. Over here we only have 1 of these NH4s. So we're going to make a 3. We're going to put a 3 here to balance out the NH4s. NO3s, we have 3 over here. Over here we have 4. So we'll need to find the lowest common multiple, which is 12. So over here I'm just going to change it to 12, and over here I'm going to change it to 3. We have 3 lead over here and 3 lead over here, and that's kind of balanced out. Let's look at the PO4s. We have 4 PO4 over here. Over here we only have 1. So we'll need to make it 4. So let's double check. 4 times 3 is 12 NH4s. Over here we have 12 NH4s as well. We have 4 of these PO4s. 4 of these PO4s over here. 3 lead over here. 4 of these NO3s over here. Wait, no. 4 times 3 is 12. 12 NO3s over here, and over here we have 12 NO3s. Just gonna make this a 1, and this equation should be balanced. I'll double check it at the end. So next question, BF3 plus Li2SO3 yields B2SO3 3 plus LiF. This seems to be a double displacement reaction as well. And we notice that this ion, or this, I think it's called like a polyatomic ion or something. Yeah, they don't separate. And let's get started. We have 3 fluorines over here. Over here we only have 1. So I'm just gonna put a 3 there. Over here we have 1 SO3s. Over here we have 3 SO3s. So I'm just gonna put a 3 here. Over here we have 3 times 2 is 6 of these lithiums. But over here we have 3, so we need to change this to 6, which changes the amount of fluorines we have as well. We have 6 over here now. We have 3 here, so let's make this a 2. And we have 2 borons over here, 2 borons over here, and that's already balanced. So let's double check. 2 borons, 2 borons, 6 fluorines, 6 fluorines, 6 lithiums, 6 lithiums, 3 of these SO3s, and of course 3 of the SO3s over here as well. And this equation should be balanced. See, there's a lot of trial and error. So nextly, we have C7H17 plus O2 yields CO2 plus H2O. Over here we have 7 carbon, and we'll have 1 carbon over here. Let's make this a 7. We have 17 hydrogens over here. And over here we only have 2 hydrogens, so we'll need to find the lowest common multiple. So it's probably 34. So over here we put 2, and over here we have to put 17. So we get 34 hydrogens on both sides. But that also changes the amount of carbons we have. Over here we have 7 times 2 is 14 carbons. Over here we have 7 so far. Let's change that to 14. And let's count the amount of oxygens we have. Over here we have 28 oxygens. 20 of these oxygens. 14 times 2 is 28. We have 17 of these oxygens over here. Let's add that quickly. And it comes out to 35. No, actually it's 45 oxygens. And we'll need to match that over here as well, but we can't multiply 2 to 45 because that's not possible, because it doesn't divide into 2. So the easiest way to do that is to multiply everything by 2, so that so that everything is divisible by 2. So 2 here becomes 4. 14 over here becomes 28, and 17 over here becomes 34. Okay, things are looking pretty epic. So let's do a quick double check. 7 times 4 is 28 carbons over here. Over here we have 28 carbons. 17 times 4, I don't know what it is. 17 times 4 is 68 hydrogens. If here we have 34 times 2 is 68 hydrogens. So the hydrogens match so far. So let's check the amount of oxygens we have here again. 28 times 2 is 56. And over here is 34. So in total on this side, we should have 90 oxygens. And to get 90 over here, we need to multiply 2 by 45. And this equation should be balanced. I don't want to do it again. Okay, we'll double check it at the end. So next equation, CaCO3 plus H3PO4 yields Ca3PO4 plus H2CO3. We notice these don't separate. Yeah, because they're polyatomic ions. I'm just gonna make this prettier. So let's try to balance this. We have 1 calcium over here. Over here we have 3 calcium. So let's make this a 3. We have 3 hydrogens over here. Over here we have 2 hydrogens. So let's find the lowest common multiple, which is 6. So over here we put 2. 2 times 3 is 6. And over here we'll put 3. 3 times 2 is 6. Right? So for the PO4s, here we have 2 PO4s. And over here we have 2 PO4s as well. So we don't need to balance it. So let's double check. So 3 calciums over here, 3 calciums over here, 3 CO3s over here, 3 CO3s over here. 2 times 3 is 6 hydrogens. 2 times 3 is 6 hydrogens. And of course, the PO4 is a balance as well. We just checked that. And let's put a 1 here. This equation should be balanced. Next we have Ag2S yields Ag plus S8. So over here we have two of this Ag, which is silver. So let's put 2 over here. And over here we have 8 of this sulfur, but on here we have 1, so this should be 8, which changes the silver as well. So let's make this, this is 8 times 2 is 16 now. So we just put 16 down. And let's double check. 8 times 2 is 16 silver, 16 silver over here, 8 sulfur over here, 8 sulfur over here. This equation should be balanced. Nextly, KBr plus FeOH3 yields KOH plus FeBr3. Again, I don't know how to pronounce brackets. So we notice this doesn't separate. Yeah. So over here we have one of this bromine. Over here we have 3 bromines. So let's put 3 over here. So over here we have 3 potassiums now. So let's balance it by putting 3 potassiums over here. And the iron's already balanced. And the OH as well, because we put a 3 here. So let's double check. 3 potassium, 3 potassium, 3 bromines, 3 bromines, 1 iron, 1 iron. Let's put a 1 over here. And 3 OH3s, 3 OH3s over here as well. And this equation should be balanced. Nextly, KNO3 plus H2CO3 yields K2CO3 plus HNO3. We see these polyatomic ions, they don't separate. This is, again, a double displacement reaction. So over here we have 2 potassiums. So let's smash that by putting 2 over here. So we'll get 2 potassiums as well. 2 NO3 over here now, but over here we only have 1. So let's put a 2 here. 2 hydrogens, it already matches. And 1 CO3, and 1 CO3 over here as well, so that already matches. So let's double check. 2 potassiums, 2 potassiums, 2 NO3s, 2 of these NO3s, 2 hydrogens, 2 hydrogens, 1 CO3, and 1 CO3. And the equation should be balanced. Nextly, PbHO4 plus Cu2O yields PbO2 plus CuOH. These OHs don't separate. So over here we have 2 oxygens. Over here we only have 1 oxygen. So let's balance that by putting a 2 here. 2 times 2 is 4. 4 coppers. So let's smash it. Over here we only have 1. So let's put a 4 here. The leads are already balanced. The OHs are balanced. So let's double check. 1 lead. Just put a 1 here. 4 OHs. 4 OHs. 4 copper. 4 copper. 2 oxygens and 2 oxygens. And this equation should be balanced. Nextly, CrNO2 plus NH4 SO4 yields CrSO4 plus NH4NO2. Let's do this. So over here we have 2 of these NO2s, but over here we only have 1. So let's put a 2 over here. over here we have two NH4s, but it's already balanced over here. One SO4 over here, one SO4 over here, one chromium over here, and one chromium over here. So let's fill this once and let's double check quickly. One chromium, one chromium, one chromium, two of these SO2s, NO2s, sorry, and two of these NO2s, two NH4s, two NH4s over here, and one SO4s one SO4 over here and one SO4 over here. This equation should be balanced. Again, we'll double check later. So next equation we have KOH plus CO3 PO4 2 yields K3PO4 plus COOH2. So I'm just going to highlight the polyatomic ions. There we go. Sorry. There we go. So over here we have two of these PO4s. Only here we only have one. So let's put a 2 here. Over here we have three of these COs. I think this cobalt. So I'm just going to put a 3 over here to balance out the cobalts. Over here we have 6 potassiums. So let's put a 6 here. And the OHs, we have 6 OHs over here and 6 OHs over here. And this should be a 1. So let's double check. 6 potassiums, 6 potassiums, 6 OHs, 6 OHs, 3 cobalts, 3 cobalts over here, and 2 of these PO4s, and of course 2 of these PO4s over here as well. And this equation should be balanced. One pattern I noticed is that, most of these equations just balance out pretty nicely. So that makes it slightly easier for me, or for us. Next equation, SN NO2 4 plus PT3 N4 yields SN3 N4 plus PT NO2 4. You can see the polyatomic ions, of course. So over here we have 3 of these SNs. Over here we only have 1. So let's balance that out by putting a 3. The NO4s over here we have NO2s. These NO2s over here we have 4 times 3 is 12. So over here we need 3 as well. So because there's 4 over here, then 4 times 3 is 12. For the PTs, over here we have 3. Over here we have 3 as well. For the nitrogens, we have 4 over here and 4 over here as well. And let's fill this with once. So let's double check quickly. 3 SNs, 3 is SNs over here. 12 of these NO2s, 12 NO2s over here as well. 3 PTs, 3 PTs, 4 nitrogens, and 4 nitrogens as over here as well. And this equation should be balanced. So, okay. Next equation, B2Br6 plus HNO3, that's a polyatomic ion, yields BNO3 3 plus HBr. So over here we have two borons. Over here we only have 1. So let's put a 2 over here. Over here we have 1 of these NO3s. Over here we have 3. So let's make this 3. We have 3 hydrogens here now. Over here we only have 1. So let's make this a 3. For bromines, over here we have 3 bromines. Over here we have 6. So this needs to be 6 now. And that changes the amount of hydrogens we have. So this should be a 6. And we have 6 NO3s over here now. And oh wait, we already have 6 NO3s over here. Looks like I made a mistake somewhere. That's okay, because we're double checking anyways. So 2 borons over here, 2 borons over here, 6 bromines over here, 6 bromines over here, 6 hydrogens, 6 hydrogens, 6 NO3s. 3 times 2 is 6 NO3s, and this equation should be balanced. So, okay. Last equation, ZnS plus AlP yields Zn3P2 plus AlSN3. Okay, so two aluminums here. So one aluminum here, two aluminums over here. Let's put two here. Phosphorus are balanced. The zinc over here we have three, only have one here, so let's put a three over there. The sulfurs are balanced, so let's put this once. Three zincs, three sulfurs, two aluminums, two phosphorus, two phosphoruses over here as well, and this equation should be balanced. So let's double check our answers. Oh wow, it's all over here. I did that, guys. I put them over here so we can compare them pretty easily. Yeah, just merge the islands. So over here we have 1, 5, 3, and 4. 1, 5, 3, and 4 over here as well. 2, 1, 2, and 3. 2, 1, 2, and 3 over here. 2, 1, and 2. 2, 1, and 2. 2, 2, and 1. 2, 2, and 1. 1, 6, 6, and 6. 1, 6, 6, and 6. 4, 7, 1, and 9. 4, 7, 1, and 9. 2, 2, 3. 2, 2, 3. 4, 3, 1, 12. 4, 3, 1, 12. 2, 3, 1, 6. 2, 3, 1, 6. 4, 45, 28, 34. 4, 45, 28, 34. This question is a hard one because there's a lot of these compounds here, but I guess we got that right. 3, 2, 1, 3. 3, 2, 1, 3. 8, 16, 1, 8, 16, 1, 3, 1, 3, 1, 3, 1, 3, 1, 2, 1, 1, 2, 2, 1, 1, 2, 1, 2, 1, 4, 2, 1, 4, 1, 1, 1, 2, 1, 1, 2, 6, 1, 2, 3, 6, 1, 2, 3, 3, 1, 1, 3, 3, 1, 3, 1, 1, 3, 1, 6, 2, 6, 1, 2, 6, 2, 6, and 3, 1, 3, 2, 1, 1, 3, 2, 1, 1. So we got 100%. Oh no, 100%. Wow, I'm so good at balancing equations, guys. I practiced this like 2 times, by the way. So it's pretty evident that I got this right. Okay, bye guys. Ask questions if you have. I'm not. I haven't done this like since like last year, so I'm pretty rusty at this. Um, I haven't taken like this in chemistry yet. Okay, bye.